Well, welcome to this online revision session for AQA FP3, which we're going to be looking at the January 2010 question 3 on second order differential equations. You can see in this particular question we're going to solve a second order differential equation by using a substitution to reduce it to a first order differential equation, which we can then solve by using an integrating factor, and having solved that we can then solve and find the general solution to the original second order differential equation that we were given. So in the first part of this question we're going to use the substitution u equals dy by dx, and so to substitute this we need to find out what d2y by dx squared is. So if we differentiate this, we will get the fact that du by dx is going to be equal to d2y by dx squared. And so we take these two things and we substitute. We're going to get x, and in place of the d2y by dx squared we can put du by dx, and then in place of the dy by dx we can replace it with u being equal to 3x, and so if we now divide through by x we get the required result du by dx plus 2 over x lots of u is equal to 3. Two marks here. Well, one would be a mark for working on the differential of the u equals dy by dx, and then an accuracy mark here for then using appropriate substitutions and simplification through to the required result. So in the second part of this question we're now going to solve this first order differential equation. So we can see this is in the form where we have differential of u and u multiplied by a function of x. So to find our integrating factor we know we have to do e to the power of the integral of this function 2 over x dx, which will give us e of twice ln x, which we know we can write as e ln of x squared, and e and ln are inverse functions, and so we just end up with x squared as our integrating factor. So in other words we've now got to multiply through by our integrating factor, which will give us x squared du by dx plus 2xu equals 3x squared. And then we can see on this left hand side we know that these two terms come from differentiating u multiplied by our integrating factor, because from that product we would get those two terms, and that equals 3x squared. And so if we now integrate both sides, that will give us x squared u equals, and this will become x cubed, and we must remember our constant of integration at this point, and then dividing through by x squared gives us u as a function of x as required. Five marks in total for this part. So initially a mark for obtaining or working on realising how we would find the integrating factor, and obviously 2 marks for obtaining the e to the 2 ln x, and then another further mark for simplifying it. And then substituting or multiplying through, by that integrating factor will give us a mark, and then integrating and ending up with the required result gives us our 5th mark. Right, and we must have that integrating factor in that expression there. Yep, the constant of integration. Okay, then on to part C. We now are required to solve the general equation. Well, if we remember, the substitution was u equals dy by dx. So we can replace u in our solution to the first order differential equation with dy by dx. So we now get dy by dx equals x plus a over x squared. And now we can integrate both sides with respect to x, and we will have y equals x squared over 2, the integral of x, and then the integral of ax to the minus 2 will become ax to the minus 1, so that's a over x, and the power is multiplied or divided through by minus 1, so this becomes minus a over x, and then again we need another constant of integration here, plus b. So again, 1 mark for obtaining or attempting some sort of integration correctly, and then an accuracy mark for obtaining from that the result that we require. Well, hopefully you found that solution helpful. For more support for your maths revision, please go to the Further Maths Support Programme website.